What's going on, everybody? Welcome back. Another episode. If you've seen the title already, I'm pretty sure that you know that this video is going to be about augmented reality, AR. All right, so if you're familiar, if you're not familiar, I'll break it down. But augmented reality is essentially the concept of bringing another world or some other computer world into our reality. That's the augmented reality part. So if you play games like Pokemon Go, where the world of Pokemon has now come into this world, that's essentially what augmented reality is. And so today, I've come across a unique Flutter package that allows us to interact with ARKit, which is Apple's software development toolkit that allows you to use AR for applications. I'm going to be using that to create a solar system, an augmented reality solar system within Flutter today. So if you stay tuned with this video and use it as a pretty helpful resource, which I hope it ends up being for you, then you can make your own solar system in Flutter in augmented reality. So let's go ahead and jump into it. All right, so like I said, today we're creating a solar system in AR, and the premise of the app is we're essentially going to be displaying each planet from the sun being in the middle, and then expanding out for, I guess, 8 planets. Don't quote me on the number, I think it's 8. But we're going to show all the planets, and as they're orbiting, we have we're going to display the path of their orbit, as well as the functionality to tap on a planet and then get some extra information, which is essentially just the name of the planet that will display within the window of the app. So very simple, but it should be enough to showcase how powerful ARKit and Flutter can actually be for what you're trying to do, or what we're trying to do, I should say. I also wanted to give a shout out to Chris Jungman. I hope I'm pronouncing your name right, but he has a YouTube channel, and he actually did a video where he was discussing how he set up a virtual solar system on native iOS using ARKit as well, but without the Flutter. And so watching that video, it actually helped me a lot when I got stuck on trying to figure out how to, I guess, anchor different objects within the world, how to make a parent-to-child relationship between different nodes or objects within the world. It actually helped with some of the hills that I was kind of stuck when it came to dealing with ARKit in that realm. So I wanted to give his channel a shout out. Be sure to check him out. His name is Chris Jungman. Again, if I'm mispronouncing your name, my apologies, but be sure to check out his channel and subscribe. Also, before we get started with the video, if you haven't already, be sure to subscribe to the channel, Trade Codes. I plan to be dropping way more. I feel like that's so cliche to say that, but I really do plan on dropping more content this year. So be sure to subscribe to the channel and like, comment, subscribe on anything. That way I know, how I can improve or what content I should talk about for next time. So just keep me locked in. I appreciate it. All right, so first thing is we need to handle some configuration setup. So the package that we're using is ARKit plugin version 1.0.7, and this is what the official documentation looks like on pub.dev. There's a few things that we got to do first. First, we need to update the info.plist file. That's because ARKit uses the device camera, so do not forget to provide the NS camera usage description. You may specify it in the info.plist like that. So over in here, in my info.plist file, I have it at the bottom, just right here, this key and string value pair. You can put anything here, but you just have to have some type of description provided for why you would need to use this permission on the device. Something also to note is for this AR example, we have to use a physical device. It won't work with the simulator, so keep that in mind as well. Then we need to also update the pod file at the top level of the iOS folder, uncomment the second line in the pod file, and change the iOS minimum version from 9.0 to the appropriate one. The minimum supported iOS version is 11.0, though if you need image anchors, use 11.3. For image trafficking, image tracking configuration or face tracking set 12.0, and for body tracking minimum version must be 13.0. So as you can see in the example, going from 9.0 to 11.0, for my example, I'm already on 12.0 by default. So just keep in mind that you need to specify to whatever you need from ARKit as far as the services that they provide on each different version. But once you do that, then you would do a pod install. I won't get into all that, but I'm sure that you understand how to install dependencies at this point. And then you're pretty much ready to actually jump into the app. All right, now I need to discuss some of the files that we're going to be using by default out the gate, just some of the setup and configuration files. And those are, first, the pubspec.yaml file. This is pretty much the motherboard or holy grail of like dependencies and where you need to put them at for whatever your Flutter app needs. And I'm going to be using the ARKit plugin version 1.0.7, as well as Cupertino icon version 1.0.2, the tuple package, which is going to allow us to use a unique return type for one of our or a couple of our methods. So instead of bringing back a specific list of something like an arbitrary amount, I want specifically 2 items, which will be referred to as a tuple of 2. So I'll explain more about that a little bit later. And then the vector math class, because we're going to be using vectors to represent positions for the objects within our 3D world. Then we have some assets that are represented by the planets. So I have, each planet has its own skin, essentially. So I have this one for Earth, and then the rest of them for Jupiter, Mars, Mercury, so on and so on. Okay. Then those are those assets. Then I have this global directory, which is just strings that represent the path to each of these assets that I just explained. The celestial info class was a class that I created in order to hold information about different planets that will be used within the world. It's going to contain the name, the size, the image, the spin speed, which is how fast it's rotating on its own axis, and then the orbit speed, how fast it's rotating on an axis that is parallel to a center or the sun. So each of these planets has information about themselves. Then there's also these 2 extra variables here, the anchor multiplier, which we'll be using to create the size of a planet that's within itself. And I'll explain more about what anchors are, but anchors aren't going to be seen visually. They're just going to be used for determining different speeds of other objects in the world. So we just need them to be slightly smaller. So it's just 0.99 for the multiplier. And then the pipe radius is how thick we want the paths of the orbits to be on each planet. And it's very small, so 0.01. And then finally the demo page, which is just the outline of the video, and then we have a simple scaffold page with the app bar that says solar system. So that's all that we need to set up. Now we're actually ready to get started creating the app. All right, so we have the app running currently on my device. I don't know if I mentioned already or not, but when doing AR, we can't use a simulator. We actually have to use a physical device. So we're using my device and just mirroring it onto my MacBook. So, which is good, because while we're debugging, we'll see these changes instantly in the AR world right here on the MacBook, so we're always in sync. So, first thing we need to do is add the ARKitSceneView and ARKitController. The ARKitSceneView is sort of like the playground where all the objects will go for our 3D world. And then the ARKitController is how we're going to be able to manipulate the objects within this world. So within the demo page states, I'll create a late variable of the ARKitController, and we'll assign this later once it's created in our ARKitSceneView callback. Then we also need to dispose of this controller. If I can override it. I have a feeling I'm doing that right. Okay, make sure I did that right. All right, dispose of that. Okay, and then down here, we can actually take out the app bar. We don't really need that anymore. We just need the body, and we need that to be ARKitSceneView. And we get a on ARKitView created callback. But actually, there's a method that we're going to create is the on ARKitView created callback. So this is what happens once the scene is created. We are presented with a controller that we can now assign to our ARKit controller, and then we can do whatever else we need to for our 3D world. So create this method here. It gives us a ARKit controller. All right, cool. Add a comma here. All right, so I hit save, and now it refreshed, and now you can see that this is currently the world that we're in. I'm currently at the library right now. But yeah, so you'll be looking at this camera for the time being. Anyways, now we need to come in here and actually assign our ARKit controller. And do that by, there we go. So now our ARKit controller has been assigned. We have our ARKitSceneView present, and this is our world. So we can knock the first task off the list. Cool. All right, now what we want to do is we want to add a white sphere to the scene. This is going to be just a white ball that's going to be present in the 3D world, and we're going to be able to like look around it, look above it, and all that stuff. But it's essentially the first object that we're going to be using in our solar system. So we'll create a new variable, we'll call it white sphere. And it's going to be an ARKit node. So the nodes, there's a bunch of different ARKit nodes. There's, actually, I don't know if there's a bunch of different nodes. There's a bunch of different geometries for the nodes, and I'll explain what those are. So the geometry is essentially the shape of the node. You can have a box, capsule, cone, face, plane, whatever. For the spheres, we're just going to use, as you would probably assume, an ARKit sphere. And we want the radius to be 0.5. All right. And let's give it a name, white sphere. What else? Position. We want it to be, it's going to be a vector 3. So the way vector 3s work is they take in 3 inputs. It's going to be an X, a Y, and a Z value. So the X value is going to be horizontal. So that's if we're specifying from left to right. The Y value is going to be up and down vertically. So that's if we're specifying how high or how low we want the object to be. And then we also have the Z factor, which is going to specify how forward or backward something is. So something with a negative value is forward, something with a positive value is backward. So if we wanted something to be to the left of us, we would specify -3. If we wanted below, -2. If we wanted forward, -1. That's how you would position coordinates within the world. So for this white sphere, we want it to be the same coordinates on the X and Y axis, but we just want it to be forward about 3 meters. So we'll say a position of 0, 0, -3. Okay. Now we just need to call the ARKit controller and add the white sphere to the scene. Okay. Now if we refresh this, we should see our white sphere present in our world. Okay. Now I'm hooked up to the Mac right now, so I can't really go too far, but as you can see, it's actually in this world. I think I'll bring it a little bit closer. Maybe like, let's see, let's do like 1 meter in front. See what that does. All right, so now it's 1 meter in front, but as you can see, like we can kind of go around it and go on top of it. That's still too big. Hold on. Let's bring it down like 1. that's more doable. Now we can go around it. I made it a little bit smaller, but yeah, so it's an actual sphere that's in this world. All right. So cool. We got our first sphere in here. And something to keep in mind is if you're wondering like where it determines the positions of the world, it starts instantly wherever the phone loads at. So if I'm looking at the ceiling, or let's say I'm up here and I start the app, then 1 meter in front of us will be 1 meter relative to where the app started at. So the white sphere will start there. If I start down here, it's going to be 1 meter in front of this position. Okay, so something else to keep in mind. But good, we got the white sphere in there. Now let's modify this a little bit. Let's take this off the list, and let's update the white sphere to be a orange sphere. If we want to do that, let's just change the name of this. We're going to change this to orange as well. Orange sphere. And for the geometry, we want to add materials to it, which is going to be a list. And we can add our own material, which will be a ARKit material. Modify the diffuse property of the ARKit material to be ARKit material property color, colors.orange. I need to add alias to this class because there's a naming conflict when it comes to the material class and the ARKit class, or I'm sorry, the vector map class. So I'm going to alias the vector 3 mentions with VM, and we should be able to use colors now. Okay, cool. So we change that to color, change the name to orange sphere. I'm going to change this back to 0.5 and put this 3 meters out. All right, let's see what that does now. All right, now we have an orange sphere. All right, same thing as before, just change the color. Cool. Now we'll take this off. Now let's go ahead and update the orange sphere to actually be a sun. Okay, so now we're going to start working with actually applying some images to some of our 3D objects. So I'm going to come back down here to orange sphere, and we're going to change the orange sphere to sun. We're going to call this a sun now. And the name will be planet.sun. I didn't do the import yet. There we go. Planets.sun.name. And remember, planets was just that class that I created with the information about the different planets. So I'm just going to call upon them based on whatever planet I need in the actual object. And the radius will be the planets.sun, planets.sun.size. And then we're going to change the color to not use a color, but to use an image instead. And that image is going to be the image on that planet. Image path. Oh, I messed up my formatting. Hold on. Planet.sun.image path. All right, and we'll add the sun back in like that. All right, now let's refresh this. All right, we got the sun. Cool, and it is the sun size. I don't know what I have it set as, but yeah. Got the sun right over there chilling, right behind or right in front of the, what do you call that? The book row, the book? I don't know, the column, whatever. Back to the app. All right, we can take this off the list. Now we need to rotate the sun because we have the node in the world, but it's not really doing anything. So we can create a method that will actually rotate a node or object within our world. We'll call this void rotate on X axis. And it's going to take an ARKit node because it's going to be, we're going to rotate whatever node that we specify, and then we're going to specify the pitch, which is how it rotates on the X axis. Now, there's something to keep in mind when dealing with nodes, there's these things called Euler angle. I don't even know how to pronounce it. I'm probably messing it up. Euler angles. I probably should have looked that up, but that's the word that it represents how things are rotating on different axes. But if we want to rotate on the x-axis, we can basically call those Euler angles and then increase the x value by a pitch, and do plus equals right there. Whoops, not that. There we go. Now, if we look at Euler angles in the ARKit node class, you'll see that it says the pitch is the rotation about the node's x-axis, the yaw is the rotation about the node's y-axis, and then roll is the rotation about the node's z-axis. However, when looking online, they have different values for different axes. So yaw is for z, pitch is for y, and roll is for x. So I'm not sure if the inconsistency is for another reason, or if the inconsistency is even known. But just know, for this example using ARKit node, when I say pitch, we're referring to the rotation about the x-axis. So since we're rotating a node on an x-axis, we want to specify it as the pitch that's being passed in. Okay, so we have the method here that's going to be increasing that. And then since this method is rotating on the x-axis, we need to call it for every frame of the app. So there's a method or a callback on the ARKitController called update at time. That gives us a time. I assume that time represents the time that this frame was called, but we don't need that variable. What we just want to be able to do is call the rotate on axis method, and we're going to pass in the sun, and the speed will be planets.sun.spin speed. All right, and we should have everything there. Okay, cool. Now if we refresh this, we should see the sun rotating. Okay, perfect. The sun is now rotating in our world, just like we need it to. Okay, next thing to do is add Mercury. All right, so we're going to add another node next to the sun, and we're going to rotate that node as well. So these nodes are going to be pretty similar, so we can do essentially a copy and paste for Mercury. We can come down here and just change the name from sun to Mercury, and use Mercury information now for the name, the radius, the image path. But we want it to be 0.5 meters away from the sun. Okay, so let's do 0.5 meters out, and we're going to add Mercury. All right, and let's see what it looks like if we just refresh that. Okay, so as you can see, we wanted Mercury to be 0.5 out. However, it's only going to be 0.5 meters away from us, not the sun. So in order to do that, we need to add a child-parent relationship between Mercury and the sun, so that it knows that this 0.5 meters that it should be away from is relative to its parent. So with Mercury, once we add Mercury, we can specify the parent node name to be planets.sun, or just do sun.name. Okay. Now if we refresh this, we have Mercury is now relative to the sun. But this also presents another issue that we'll face a little bit later. But as you can see now, the Mercury's orbit speed, or how fast it's rotating around the sun, is now strictly based on the sun itself. And it's starting to slow down, so I'm going to have to clear this out because it's starting to bog down a little bit. But all right, well, we're just going to keep going along. I think if I clear something out, it should clean up a little bit later, but I'll cancel it out for now, maybe just to give it a break for a second. But we need to, we added Mercury in, but we now have it specified as a child to the sun, but we also want to be able to specify it as having its own orbit and its own spin speed. And that's something that we'll add a little bit later, but just know that now that we've added Mercury in, we can also rotate it on its own axis for right now. So we'll add in another call to rotate on x-axis, and we'll pass in Mercury this time. And this, we will use Mercury spin speed, okay? So I'll load that back up, but we can keep going with the presentation. But now that's how you would rotate Mercury or whatever planet that we pass in. This is how you would rotate them individually, okay? Now we want to have Mercury orbit the sun. I believe we technically already did that by having it become, we did that already by having it as a child to the sun. So we took care of that. Okay, now it's kind of back up to speed, which is good. So we've already taken care of that. It's now orbiting the sun because it is a child to the sun. Now we need to build an orbit path for Mercury, okay? And the orbit path is essentially going to be, it's another ARKit node, but it's going to be slightly different because instead of being a sphere, we want it to be a ring because it's going to be a ring around the sun, which is the orbit path that Mercury is taking. So similar setup, so we can copy and paste, fortunately. So we'll come right here and we'll change the name of this to orbit, and we will give it the name orbit, and then we should get a fix here for a better way to write that. All right, better way to write that. And instead of ARKit sphere, we're going to use ARKit torus, which is like a ring shape. And its property is a ring radius, okay? And that ring radius is going to be how far out Mercury is from the sun. So we can get that position by passing in Mercury. We know that it's 0.5 meters away from the sun. So we're going to specify that as the ring radius, Mercury.position.z. Now something to keep in mind is, however, the z value for Mercury is negative 0.5. So if we specify a negative value for our ring radius, it won't show up. So we have to do the absolute value of that value to ensure that we get 0.5 meters for thickness, or I mean as far as how far the ring radius is, okay? And then the materials, we can actually take these out because it's just going to be a white ring and it's going to be relative to the sun. All right, so we hit refresh. Okay, we don't see it. Oh, we didn't add it, that's right. Let me add orbit. All right, so the orbit is there. However, we didn't specify the pipe radius, how thick it should be. So as you can see, it's still in the world. The sun's in the middle, but it's too thick right now because we didn't specify how thin. So if we come back to ring radius and then go down to pipe radius and then specify pipe radius to be that global value. Remember I said pipe radius is 0.01. Okay, now if we try that out, we should get a more suitable pipe radius. All right, perfect. So now you can see Mercury is orbiting the sun, and we have the orbit as the white ring that is around the sun, and the sun is spinning on its own axis. Perfect. Okay, take this off the list. All right, so now we need to add a helper function for building our celestial body. And we can do that simply by taking the information that we have for building the sun and just create a generic function off of that information. So as you can imagine, we're going to return a ARKit node, and we'll call this build celestial body. And it's just going to return pretty much what we have for the sun, but we're just going to make it generic now. That way we can use it for whatever planet we decide to use. So we're going to need a name to pass in. We're going to need a size to pass in. We're going to need an image path to pass in. And then we're also going to need a position to determine where this planet is located in our solar system. Okay, so now we can come down here where the sun was built and use that method, and we're just going to pass in everything that we need. So planets.sun.name, and we also need it for the size, and we also need it for the image path. And then the position is VM vector 3 0 0 -3, because it's 3 meters in front of us. All right, so now if we refresh this, you should see everything's still the same. Okay, cool. And that means we can do the same thing for Mercury then. So I'm gonna use that to build Mercury. Its position was negative 0.5 meters from us. So yeah, okay, we do that. Oh, and then change the sun to Mercury. All right, so if we refresh this, everything should still be the same. All right, cool, got that in there. All right, now we'll create the method for building the orbit, and we're going to do the similar thing. Just take everything that we have that currently creates our orbit and make it a new method. So ARKit node is going to be returned build orbit, and we're going to pass in an ARKit node because that's the only information that we need to build the orbit is whatever node we need to build the orbit for. So take out Mercury, replace that with node, and then take out Mercury here as well. Replace that with node. And now we can just use our build orbit method down here for our orbit. And the node that we're passing in is Mercury. All right, so we hit refresh on that. Everything should still be the same there as well. Still got Mercury orbiting the sun. Perfect. All right, now we need to create the anchors for Mercury and the sun. Well, the anchors that are inside Mercury and the sun. We need an anchor inside Mercury, that way it can be independent when it comes to determining its spin speed, and then an anchor inside the sun so it can be independent when determining its orbiting speed. Okay, so first I'll explain that just by demonstrating. We need to create an anchor for Mercury. It's going to be the same thing as Mercury, except it's going to be slightly smaller and different naming convention. So we'll add name anchor here, and we should get a fix for that. And then it's going to be slightly smaller than Mercury because it's going to be inside Mercury. So we're going to multiply it by our multiplier. And remember that multiplier is 0.99, so our size is just slightly smaller with the inside itself. We'll keep the image the same and the position the same. And when we add it, we currently will have the sun as the parent, but we're going to change that in a little bit. But then for Mercury, we no longer are going to be 0.5 meters away from the parent, because our parent is now going to be Mercury anchor. So we need to be relative to that position. So we're just going to be at 0. Vector 3.0. Okay. So, and we also need to update our build orbit to now use our anchor, because that is the node that has the position away from the sun. Mercury is technically relative to its parent now, so it won't be useful in determining how big the orbit should be. But Mercury anchor is going to be negative 0.5 meters away from the sun. So we're using that to build our orbit. So now, if we refresh this, everything should still be the same. All right, so, oops. Still got everything in there. Now we need to create the orbit for the sun, or the anchor for the sun. So same thing for Mercury anchor. We'll copy and paste that, and I'll just add sun anchor in here. Let's take that space in the anchor. Sun anchor. It's going to be the size of the sun, even though this doesn't really matter. We'll use the sun for the image path, and then its position will be the sun's position, because it's going to be directly wherever the sun is at. Sun.position. Okay, and when we add the Mercury sun anchor, we don't have a parent here. So it's completely independent of everything. The Mercury sun anchor is the hierarchy of where the nodes start. So then its child is the sun. The Mercury sun anchor, Mercury anchor, and then Mercury. And that's the parent-child relationship on the way down. So let's make sure that everything is right. Mercury anchor is now listening to the Mercury sun anchor. Mercury is listening to Mercury anchor. Okay. And if we refresh this now, we'll still see everything. However, we won't see Mercury anymore, and that's because the Mercury Sun anchor determines the orbit speed. And since Mercury Sun anchor currently is not rotating, that means that Mercury, which essentially is listening to the Mercury Sun anchor at the top, is not going anywhere because Mercury Sun anchor its position is stagnant. So in order for us to see Mercury again, we need to update this to use the Mercury anchor for the spin speed, but then also update the Mercury Sun anchor to now update the orbit speed. Okay. So now if we refresh this, we can see Mercury rotating around the sun again. All right. So everything is how it needs to be, and we can test it actually by every speed should now be independent of each other completely. So if I update the sun's spin speed to something astronomical, it shouldn't impact Mercury's spin speed or orbit speed. All right, as you can see here. Now, if we try this again and update Mercury's spin speed, let's see here, refresh that. Mercury's spin speed is now astronomical, but it's not changing anything with the sun or how fast it's orbiting, which is good. And then finally, if we update the orbit speed to something astronomical, it shouldn't interfere, even though it's hard to validate this one, but I think it's safe to assume that the speeds are independent of one another, which is exactly what we wanted. All right, now we need to create a helper function for creating the node, the anchor, and the orbit. So this is a function that's essentially going to do everything that has up until this point created actual Mercury, the two nodes corresponding to it, as well as its orbit. So we're going to make a function that's going to do all this for every other planet that we're going to be using. That way we can dynamically build the solar system without having to manually put in information for each planet. So I'm going to copy everything from the creation of the orbit up until the creation of the sun anchor. And this is where we're going to be using that tuple data type. And we're going to be bringing back two ARKit nodes. It's going to be the anchor and the sun anchor, because those are the two nodes that we need to determine the spin speed and the orbit speed. So the tuple2 will be used here, and we'll call this method build connection. And we're going to pass in a celestial info, which is going to be whatever planet we specify, as well as the distance from the sun. Distance from the sun. Okay. And then it's going to work all the magic that we have currently in here, but we need to update this to be more generic. So instead of Mercury Sun anchor, I'll say node sun anchor, and it's going to be whatever planet we specify. We can keep the sun size the same. The position that we have for the sun, which was this right here, I'm gonna put it right here for the node sun anchor. Realistically, it would make more sense to pass in that sun position just so that we know that it's never changing, but just to demonstrate exactly where the sun anchor position is coming from, I just want to paste that in there directly. So then pass in the node sun anchor here. We'll change the name of Mercury anchor to node anchor and change that to c.name. This size is going to be the planet size. Image path is going to be the planet image path. And then this will be the distance from the sun, okay, that we specified, because whatever node that we're currently dealing with is going to be, let's say it's 0.5 meters or 1 meter. We want the entire orbit corresponding to that planet to be a meter out as well, and so on and so on. So we'll pass in the node anchor here, and its parent is the node sun anchor. And then for Mercury, we're changing this just to be node, as generic as possible. And then change all these to be c.name, c.size, c.image path. And pass in the node for our scene, and then the anchor, node anchor. And the node anchor we'll use to be building the orbit. Then we have the orbit, and its parent name is going to be planets.sun.name. Okay. Now remember, this is a tuple type 2, so it needs two nodes brought back, and those two nodes, as I mentioned, were going to be the node anchor and the node sun anchor. Okay, and so now we can actually use this right below the creation of the sun. So we'll create a variable called Mercury nodes equals build connection, and we pass in the planet for Mercury, and the distance from the sun was 0.5 meters, and that's all we need to do there. And so now down here, instead of using those nodes directly, we can call them from the tuple by using item.1 and item.2 on the tuple itself. Okay, so now if I refresh this, we should still see everything intact. Okay, still got Mercury going, but the real test would be if by adding the other planets, does this still work? All right, so let's add some more planets here. So below Mercury, the next planet is Venus. So let's see what happens when we add Venus nodes. Venus, it's going to use the planet Venus, and it's 1 meter away from the sun. And we still want Venus to rotate in orbit. So we'll just update these to use Venus. And now refresh that and see what this looks like. All right, so we got Venus added in here now. Please excuse the speed, it's going very slow right now. I don't know if it's just CPU usage or what, but it's moving kind of slow. But as you can see, we have Venus in here and we have Mercury going. So it looks like our helper function is working. So let's go ahead and add the other planets in here. I'm going to fast forward this part just because it's going to be, oh, there we go. Now speed it up, all right. I'm not sure what triggers that, but okay, now that that's back going, let's go ahead and add some other planets. So we got all the planets added in there. So if I take a step back and look at that, you should be able to see now. They're still moving a little slow. Sometimes it'll just start speeding up. I don't know if it's CPU issues or whatever, but we got all the planets in there currently. Something cool to look at as well. Some recursion happening there. But yeah, we got the whole solar system in here now. And it's building the orbit paths based on where the child is at. You can rotate the camera like this, go under, however you want to do it. Cool. All right, so let's add a few more features before wrapping this app up. So I want to be able to tap on a planet and then get the name of the planet displayed in the window. So in order to do that, we'll create a on tap feature. On node tap, it's going to take in a list of string, which are the names, and we're going to display in a banner. So we first need a state of the scaffold messenger. Scaffold messenger dot of context. And usually when I can't remember the type of an object, I just assign it to something first and then get the name of it and go from there. All right, so from there, we want to show material banner, and then we need to pass in a material banner. And the content is going to be a text that just displays the first name in that list. And I'm not sure, the reason we're passing a list is because that's what's given from the callback for the ARKitController. For some reason, when you tap on different objects in the world, it brings back 2 names of that object. So we're just going to display the first one, which should give us the desired effect that we want. And then the action is just going to be a text button that all it does is close the current banner. So we'll call that scaffold messenger state hide current banner. And the child is going to be a text that says dismiss in all caps. Let's add the const there and add our missing commas. All right, cool. Now we need to assign this function to our ARKitController. We can do that up here or down here actually. So ARKitController dots on node tap equals on node tap, and then we also need to enable tap recognition for our ARKitSceneView. So enable tap recognizer set to true. All right, so now let's refresh this, and if I tap on the sun should pop up. If I tap on Venus pops up. What about Earth? Got Earth. All right. You can even tap on the orbits themselves, and you'll see the orbit info pop up as well. Okay. Cool. And last but not least, we want to be able to refresh the UI inside the app without having me as the developer do it. So we're just going to create a floating action button on our scaffold here, wherever that's at, right here. Okay, create a floating action button, and the on pressed is we're going to rebuild the state because we want a refresh button. So we want to rebuild the state, so we'll call set state, and then in here, we also want to dispose of our ARKitController because when we refresh, we don't want that to be lingering around. So we'll dispose of that in our state method. I really like to do lambda functions a lot. I believe this is what you call it, a lambda function. There we go, it just looks better. All right, so we dispose when we tap that button, but we need an icon because right now, the button doesn't have an icon. So refresh, add the const modifier, and we should now have, yep, we have it down there. Okay, so one more thing we need to do is for our ARKitSceneView, we need to apply a unique key. In Flutter, all widgets have a key that pretty much makes them identifiable, and if the unique key is different, that means, okay, we need to build something new. We need to force a build. So by giving it a unique key every time, that forces us to automatically rebuild the complete playground or UI or ARKitSceneView every time we hit the dispose button or the refresh button, I'm sorry. So let's try it out. If I hit refresh, it starts the UI over again. Let me try moving around a bit and refresh it. So if I move over here and hit refresh, all right, just rebuilt there. What about if I'm down here and hit refresh? All right, rebuilt there. Perfect. Looks like it's going everywhere it needs to now. We are here, refresh. Perfect. And that is the solar system using ARKit and Flutter. All right, so that is essentially how you would make a AR augmented reality solar system within Flutter using the ARKit plugin Flutter package. So as always, if this video was helpful, please like, comment, subscribe. Let me know if you're using anything AR related in your apps, if AR is something of interest to you, or what other cool AR things that you're currently working on. I'd love to hear about that as well. So as always, if this video is helpful, let me know. And until next time, I'll be scheming up some other cool technology that I can get my hands on or figure out and try to unpack a little bit more than what I already understand today. So until next time, this is Trey Coles, as always, signing off. Enjoy the rest of your day.